I'm just experimenting with a series of test cuts here, trying to get using the new carbide roughing end mill from Lakeshore Carbide. I'm kind of working up to one of Carl's recommendations, and I thought it was going pretty well, but I encountered kind of a problem. You can see right there. You see how the x-axis stutters back and forth. It made the cut, but it made me think that I was overloading the x-axis motor or something. But the more I thought about it, the more that it makes sense. Here it is with a 3/8 inch roughing end mill, still doing it. Kept having to back off the load of cut to try to prevent it from doing that. Still doing it here. This one finally made it, except it kind of jumps right at the very end. So I'd never encountered anything like that before, and I figured, okay, there's got to be some kind of problem under the table. And maybe the last few weeks I've noticed that when indicating the x-axis, it seemed kind of mushy. The needle seemed a little bit mushy there on the indicator. And you can see I'm just pushing the table back and forth with my hands, and it's swinging about 5 thousandths to each side. So there's definitely a problem here. It just requires so little force to move that table, being on the linear ways, and so I tried the y-axis, and the y-axis doesn't have anything close to that. It moved a little bit, but probably a thousandth at most. So I thought something must be loose. So right there, I found that nut was loose. And I ended up tightening it as much as I could, basically just snugging it up, and that virtually eliminated that problem. Now I could only move the table a few tenths when I push on it pretty hard. So back to cutting. So that pretty much took care of that issue. I accidentally ran that cut right there when it was in rapid mode, so that went 100 inches a minute. It actually made the cut okay, and it didn't hurt the end mill, but it kind of didn't sound great. So here's the cut that Carl recommended here. It cut fine. It sounded a little bit rougher than the last cut, which was the same, but it was 50 thousandths with the cut instead of 70 thousandths. So I moved on to a 1/2 inch finishing end mill, and this one's actually from Maritool that I still had left over. All my other ones got chips all over the cutting edge down at the bottom. So I wanted to, I've never been super satisfied with the surface finish that these leave. I'm just kind of messing with it again. And I never really did get a really nice surface finish. I played with adjusting the width and the depth. I've done all this before too, but I just kind of wanted to revisit it. I specifically wanted to increase the depth, because on my finishing passes I'm taking a 50 thousandth depth of cut and a 5 thousandth width of cut, which is removing very little material. That's what I found leaves the best finish, but it takes forever. So I wanted to play with increasing the depth so I can use more of the flutes of the end mill. So I'm going all the way down, taking a 3/8 inch depth. I wondered if maybe increasing the width, the radial load, would maybe help stabilize the cutter a little bit, make less waves. That seemed to be the case when you're taking a very shallow depth, but when you're taking a kind of a deep width like this, 3/8, seems like the shallower the radial cut, better. So this is the one I ended up thinking had the best surface finish. Only 2/1000th with the cut, 3/8 depth. In an effort to try to force more coolant down into that bore when the end mills are cutting, I decided to go ahead and relieve some of the top part away at this step before I drill and mill the hole. So this is a 3/8 inch rougher, and it cuts just fine. I still get that sort of jumping as the cutter is leaving the material, and I'm not sure if that's due to backlash or some kind of, I don't know, deflection. It was definitely much worse when I was having those backlash issues, when that nut was loose, and then when I tightened it, it seemed to have gone away. Now it sort of comes back, so maybe I need to tighten it more. So now that the top part is relieved, I go ahead and spot and then drill the bore as usual. So here's the roughing end mill using Carl's parameters. It's 476,000th depth of cut, and I actually backed it off a little bit to 50,000th width instead of a 70,000th, because the 70,000th seem to have a little bit of squeal and chatter and things like that. But it seems to cut okay. I was really trying to make sure those nozzles are pointed down to that bore so I'll flush any chips out of the bottom, because I think it's recutting these chips is what's damaging my end mills. But this end mill didn't sustain any damage. Now with the finishing end mill here, I'm playing with a new set of parameters. This is a 3/8 depth of cut, and 2/1000th width of cut. And I'm getting a lot of chatter, and you can really tell on the finish. So I got to come up with a different way to do this, or just go back to the old parameters. It takes a long time. It's not that bad, but when it was chattering, which was sort of in the negative Y direction closest to the movable vice jaw, that's where most of the chatter was. On the opposite end, it wasn't as bad. And then I just flip it over and drill the gas tube hole. Nothing special here. The next 10 minutes are going to be pretty boring. Feel free to skip ahead. This is a drilling cycle here. Same parameters I use for the gas block, except there's no pet. I just wanted to try it without a pet. And this is going straight through a 1/2 inch piece of scrap material there. Enormous chips, so I don't know if I'll keep this or not. But it works okay. So what I'm doing here is I've never been completely satisfied with the finish on the bore by interpolating the hole. It is nice and smooth, but I just feel like a boring bar should be able to do a better job. So I'm revisiting the idea of using a boring bar. I tried this before and I could just never get a good surface finish. And I'm not really getting a good surface finish now. So this is just a series of cuts, experimenting with different parameters, different depths of cut, different RPM, different feed rate. I welcome any feedback from anyone who can spot what it is that I'm doing wrong here. But I just simply can't get a good finish with this boring bar and insert combo. That's a 1/2 inch boring bar, by the way, carbide. Even when it starts to look like it's a decent looking hole on camera, it's actually, in person, it's pretty rough. Like sandpaper. So I kind of gave up on that again. I'm trying a C6 braze carbide boring bar here that came with my Criterion boring head. Surprisingly, this left the best finish of all. I'm not really sure how you're supposed to use these though, because there's no flat on the shank of the boring bar to where you can get the rake angle just right. So I just kind of put it at a really negative rake, basically where the tip of the carbide insert is at the outermost tangent of its rotation. Even though it looks pretty good, it's the best finish by far, it's still pretty rough. So Carl suggested taking an even deeper depth of cut to try to do the full length of the gas block in 4 passes instead of 5. So here I am trying a 600,000th depth of cut. Working up to it just to make sure I don't damage anything on the end mill or anything. And based on this, I was extremely impressed with both the end mill that didn't sustain any kind of damage, and this cut right here specifically. This is the most aggressive cut I've taken with this end mill yet, and it's removing quite a bit of material there. And it cut just fine, and it sounded great. So I was really excited about that, and that will actually save me a lot of time when roughing out the profile of the gas block, which I'm doing now. So if you remember from the last video of the cam simulation footage, I start out by removing the bulk of the material with these spiral tool paths. Now you got to keep in mind that in production there's going to be blocks on each one of those bolts, so it'll actually be doing this to 2 blocks at a time instead of just the 1. So since I've increased both the depth and the width of cut, I slowed the feed rate down to it's now 22 inches a minute, whereas before I was running at 38 inches a minute. A little bit of chatter, not bad. I wonder if a variable flute rougher would be better in this situation. Because I got two things working against me here. The length of that end mill and the height of the workpiece that's sticking up. Which kind of degrades the rigidity of the setup. I played around with the overrides of the spindle speed and the feed rate here just to see if I could minimize the chatter. And the thing that helped the most was reducing the spindle speed a little bit. It didn't completely eliminate the chatter or anything, it just kind of maybe incrementally minimized it. This cut is not a big deal for the spindle motor. Like I said before, the main issues with this cut is going to be the rigidity. And there it is with the bulk of the material removed, which worked out really well. It leaves the typical roughing finish, but this side clearly shows some evidence of chatter with the ripply marks there. So here we go with the full profile roughing operation. I was quite pleased with this cut as well, because it's removing a lot of material, particularly right there. About 1/8 of an inch of material there. But it handles it just fine. And doing it in 4 passes instead of like 50 passes like I was doing before is just going to be an enormous time saver. I just think that's amazing. It's just like erasing the material away. There it is. I was quite pleased with that cut. Even though it looks rough, I mean, it actually, the surface finish isn't that bad. It's just kind of, got a lot of lines in it. Anyway, here we go with the finishing operation, which I'm not happy with, but I'm taking the deeper depth of cut down to 375 thousandths, doing a 2 thousandths width. That's what I left behind, but with the rougher. A lot of chatter on this cut, and I'm wondering if I need to go with a variable flute on this one. I've had really good success with variable flutes in the past with eliminating chatter. If anyone would like to offer some recommendations on a finish pass here, please do so, because I've never been happy with really any of the ones that I've done. The best I've seen to have gotten in terms of surface finish is a 50 thousandths depth of cut and a 5 thousandths width of cut, which takes forever. It does that piece in like 7,500 passes, something like that. This finishing pass previously ended up being the longest operation by far. So I'd really like to be able to speed it up by taking a deeper depth of cut, which is what I'm trying to go for here. Just too much chatter to get a good finish. And there you have it. You can see all the waves and ripples in there from the chatter. It's not terrible, but definitely not as good as the previous operations I was using. I'll show them side by side here. So the one on the left is the one we just did, and the one on the right is the one I've done before with the 50 thousandths depth. it's almost hard to tell, but the finish on the right is significantly better than the one on the left. But anyway, that was a lot of work. That's it for this week. I'm pretty well beat. But thanks for watching and stay tuned for the next video.